Hi, I am Patricia Parlevliet, guest lecturer at the Faculty of Aerospace Engineering at Delft University of Technology. And in this video, I will tell you about the environmental impact of each life cycle. Today, not much information is available on the environmental impact of each separate life cycle phase. Collection of this information is a daunting task because there are so many different impacts that each phase can have. For example, energy consumption for high-performance computing, for digital design and manufacturing, mining of raw materials leading to local pollution and health risks, emissions in the operations phase, and waste production at an aircraft end of life. These environmental effects can be quantified using a life cycle assessment. This is a standardized method of calculating the impact of a product on the environment. There are 4 types of impact categories: environmental impact, used resources, waste type, and output flows. Relevant examples of environmental impacts are, of course, global warming potential, that is represented in kilogram CO2 equivalent, as well as depletion of natural resources, human toxicity, and air pollution. Used resources include energy resources such as coal or wind energy, and use of fresh water. Waste type includes disposed hazardous, non-hazardous, and radioactive waste. Output flows are components for reuse, materials for recycling, materials for energy recovery, and waste incineration and landfill, the latter 2 being the least desirable options. If you want to know more about LCA for transport, please see the links under the Additional Reading tab. So, if you would make a qualitative estimation of the climate impact in CO2 equivalent for each life cycle phase as it is today, the results would look roughly like this. Now, what do you see? Estimations of the operations phase impact on climate change range from 85% to 98% of the total life cycle impact. The rest comes mainly from the manufacturing phase, including the mining of raw materials. So rightfully, most solutions presented in this MOOC target the operations phase with new propulsion technologies and other types of fuels to reduce the emissions. When these solutions become successful, the above picture may change to this in the future. For example, in the year 2040. This picture shows a relatively larger contribution of the other life cycle phases, especially for manufacturing, if we do nothing. Previously, I introduced you to the life cycles of an aircraft. It was explained how many decades materials can take from idea to an aircraft's end-of-life waste. And now you know that environmental impacts can be quantified using a life cycle assessment. As you have seen, today an aircraft life cycle is mainly linear. Why do you think that is? Please describe your thoughts in the discussion forum below. Three, 2, 1, 0. Okay, right. It was mentioned at the beginning of this sequence, where the design phase was described. In the current linear life cycle, the main drivers of the design process are weight, cost, performance, and safety. A linear life cycle is also often described as take, make, use, dispose. The result is that a lot of fossil resources go into an aircraft and emissions and waste come out. Environmental impact was, and sometimes still is, not part of the equation. So how can we change that? We believe that for sustainable aviation, we need to move to a circular approach, which starts at, you guessed it, the design phase, life cycle design. Life cycle design is the environmentally sound design of products based on the whole life cycle, starting from exploitation and processing of raw materials via pre-production, production, distribution, to use and returning materials back into the industrial cycles. The target is to reduce the environmental impacts for the whole aircraft life cycle. This idea is represented by our following coat of arms, which we will use throughout this module. So, let's move on with the first phase, design.